Okay, so as Anne mentioned, my today talk is about like UISurf agentic platform. So basically, so in the first part of my presentation, I'm gonna focus into the research aspects and how UISurf is actually has been implemented, and the reason why I wanted to not only demo the platform itself, but also kind of showcase how this multi-agent system was implemented is because right now we are getting close to do the first release of this open source project. So we're gonna be actually be presenting this into the Agentic AI Summit into the coming weeks into the University of Berkeley. So, and the reason why we wanted to kind of like showcase not only the demo but the implementation is because we would like to people to start joining our Discord community and contribute if you feel like this is something that you can you got interested on and you are doing research in computer use models or computer use multi-agent system or so on. So you are welcome to join. So this is the Discord link to join. So feel free to reach out also to my LinkedIn if you have any question. I have set here my website URL when generally I publish content about AI, agentic AI, generative AI in general. So if you have any question about this presentation, just let me know. So a little bit about myself. I work as a research scientist for Texas A&M University. In the last few years, has been focused on multimodal AI, multimodal agentic AI, and today's talk is about like UISurf agentic platform. The idea behind of UISurf is just imagine like a team of specialized agents that are able to interact across like different environments to help you to automate tasks that go beyond of like just interacting with your workstation or local computer. So just to make an example, I'm gonna show the video as well where you can see the software running. Imagine that you have like um, you want to use your phone to grab some information to collect a picture, and then you want to use that information and pass that to the other agent to do something else. So it's basically like a surface or like a playground where all of these agents can collaborate each other, and so you can use proprietary models like Gemini, OpenAI models, but you are also open to use some other open source models out there that you can use. And so the main reason why we build UISurf agentic platform as a research project, so indeed we're gonna be publishing soon as well the preprint version of the paper, is that we wanted to provide a platform where people that actually is playing around with computer use models, they can plug and play their model. Generally, generally what happens is that you have a multimodal, and on top of that, the multimodal you fine tune that multimodal model for computer use and UI understanding, right? Because the model need to be aware about like how to understand user interfaces and be able to reason over them. So that's mean that this is generally like the pipeline. You have like a baseline model, and then you fine tune for this specific application use case. But if you are a researcher and you wanted to have a playground where you can play around with these models, but on top of that, you want to get some information out of it that guide you about the performance of the models itself or the agents. So so right now there is not so many open source alternatives out there. So this is why we decided to build UISurf. So today, roadmap is my talk is gonna be like I'm gonna discuss or introduce a little bit about the problem behind of like why these kind of solutions um, like can be useful in the from the research aspect of as I mentioned before, like researcher working or user or practitioners or engineers working on like playing around with computer use uh, models. I also gonna talk a little bit about some related work that we have today and how this platform is a little bit different of them. So I'm gonna introduce the platform architecture. I'm gonna talk about like how we build the platform and from the high level perspective, but also from the low level, thinking about like uh, I'm just gonna mention not only the high level components of the implementation itself, but also how the reasoning loop happens in the orchestrator layer, but also how every UI agent, we basically create like an abstraction of UI agents. And from that abstraction UI agent, we could have like mobile agent, or we can have like a desktop agent, or we can have like browser agent. So it's basically like, um, so then this provide us like a way to extend and create more specialized agent in the future as we need. So we're gonna talk a little bit about also those uh, low level details of the implementation itself. So we're gonna talk about how the orchestration happens, which is the core of this platform, because um, overall this platform just provide an agent-to-agent based architecture where you have specialized agents that are running on different UI environments, and then so you just plug and play them with the orchestrator using agent-to-agent protocol. So agent-to-agent is protocol is just the standard that they use to interact each other and track the context and the memory itself. So we are like working hard to improve not only the reasoning loop of the agent, but also, like the previous presentation was really good when it provided an introduction about like the different memory types and these kind of things. So we are looking how we can improve the memory of the system itself, so to make the agentic loop more robust. So we are also discuss about the limitation and what is the research agenda of this project. As I mentioned, this is something that we are about to release. So if you feel like this resonate with you, feel free to reach out, and we're gonna be happy to collaborate. So let's talk about a little bit about the problem itself. Computer use agents are hard to build, but also to evaluate for a bunch of different reasons. Like one is just if you use a commercial product, you don't need to spend so much money like um, in tokens. Like a very multimodal, being like a multimodal application. So you're gonna spend more tokens on this kind of application if you compare that with some other like a code generation, these kind of things. But also, so what about if you have an open way models and you want to plug and play there and see how that model works? Or what about if I would like to have like an observability layer where I can only see how the agent is performing, and trying to kind of like uh, navigate into the user interface and how you can see in real time what the agent actually is doing, but also how you can track every action that the agent is executing. So then, so this is about some of the problem that we have tried to identify while like researching the state of the art of the similar implementation of project that has been um, like has been kind of like published before. So one, as I mentioned, is the tax cross UI boundaries. So in real life task, like something that happens very often is that to solve a specific task is required not only to interact, for instance, with your file system, but also to open the browser, or maybe um, if you want to grab some information for your mobile phone, how you can actually connect that, and all of this. So basically, we don't have this traditional path anymore, where so we just send the prompt and we get the output, and that's it. Right now we have this agent that they can actually go through and navigate through your computer, have access to the files, use this information as a context, pass that to the model so the model can make decision on that. There is a lot of context compassion happening under the hood, because you have like a, imagine like a, I don't know, just to give you a random number, you have like a huge code based project, and so you can actually fit all of this into the context of the model itself. So that means that you need to have some kind of compassion techniques where the context is split, but the agent is still having retained the most important information to be able to understand the code structure and your project itself. And this is another contribution that we have here. We have implement different techniques to do the context compassion, and be able to kind of set up, like if you have a browser agent, for instance, that is going to navigate through your browser environments to execute tasks. So you can define some parameters like how many images you want to keep in the in the in the memory, but also you can in the memory backlog. But you can also decide like what kind of compression technique you want to apply for that. So we are exploring different techniques that are going to be implemented in the first release. So then, and this is somehow related with the executed needs and the managed of the state. So so something that happen very often. Like when you are using this um, code agents application like Codex or Cloud. So basically, you interact with them through natural language text. So then you like as give a task, and then so you have like an orchestrator, and the orchestrator is able to figure it out based on the information that have the context about your projects. So which are the files that need to be edited. Um, but sometimes, like if you want to kind of like, hey, I would like to grab some information or file that I have in Google Drive, there is like some kind of authentication layer there that it may require the 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 agent to use another skill to be able to open the browser and go there, go through the authentication process and these kind of things. And in terms of interpretability, I think that right now, because this tool has been just natively incorporated into the agentic loop itself, we don't have like an isolated way to evaluate them independently. And if you want to actually kind of identify so the reasoning trace of the models or what's happened while the model is or what actually basically generally the way that you interact with this computer use model is like headless, so you don't really know what is going on under the hood. But for some application, it could be great if you can see exactly what the agent is doing and be able to log all of the reasoning traces, because at the end, all of this information is what you can actually use to self improve your hardness. So then there is a need and to have like a real playground when researchers and developers they had in one place this platform where they can run, observe, compare, and evaluate computer use models and see how they can perform and how smart they are, understanding the different interface boundaries, because it's not the same interact with like a browser UI, but and interact with a mobile UI, like some of these models have been fine tuned um, generally for both application use case. But if you want to kind of train your own model on that, or if you want to kind of evaluate your own model, imagine that you want to create a Gemma version for computer use, for instance, or you want to use like, um, I don't know, like Llama model specifically for computer use. It will be great if you have this kind of playground where you can, again, plug and play your model and see what is going on and how the model is performing. So the core premise is browser only, desktop only, and mobile only agents. Each of them resolve different problems independently, but on a practical workflow, what you want is like be able to orchestrate all of these agents and be able to serve or navigate through all of them, to all of these kind of different UI environments to be able to solve like real life tasks. And there is some evidence that agents still struggling with this. Like this is one of the papers that recently have been published about like uh, like the web arena is one of the well-known benchmark to evaluate agents that can navigate to web pages and navigate through the browser. And there are some others that have been reported that this is still like being a challenge problem. So that means that um, we need to get back to the foundations and extract all of this complexity behind of evaluating these models independently and provide like a tool that when we can observe how these models are what actually are doing before to connect that again into the agentic loop. So so then the research question is about like how should an agentic platform orchestrate natural language or multimodal tasks that require the interaction with multiple graphical environments or multiple AI UI environments. So in the way that we actually uh, study this question is like let's start simple, like delegating responsibility and kind of create agent to agent complaints, standard agents that can run in the different environments separately. And then we're going to have an orchestrator there that is able to kind of not only plan the execution of like how is they going to be the interaction between them to be able to solve a given task by the user, but also to understand in what moment the orchestrator need to switch from one agent to the other one. So so we basically have this kind of like task queue where the orchestrator can always go there. Well, we actually have an orchestrator, but we have an automation agent, and the automation agent is who actually delegate which agent to be called to and he actually identify like what is the state of a given task that has been assigned for one of those agents. So and we also talk about like if we wanted to provide a tool that is going to interact with the browser, and we're gonna have also a desktop environment. So we would like to build this tool like with a safety in mind. So that's mean that all of the sections that run the agent itself are isolated and they run in a sandbox environment. So that's mean that this avoid that any issues like the agents asking to like information the user may want to expose. And at the same time, like something that we also implement is that we implement this section management system where so you can actually log in into the platform and I started playing around with the agents, but in any moment you can just leave and you can actually log out from the section, and the agent they're gonna keep running in the background. Like there is one of the big things these days is like long running agents on agents that are able to run in the background, and this is something that we consider for this first version that we implemented. So you just have this sections queue where we but when we actually store or persist the sections, and then in that way, so because for every agent or for every automation we have like an isolated sandbox, so the agents can actually keep working on doing the thing, and we can go and we can log out from the platform itself and get back. So so there are different um, related work that has been done regarding the use of the application of use of the computer use agents or computer use models to focus on in be able to understand and interact with the different user interfaces. So OpenAI and Tropic that they have done like a really good progress in this sense. If you are familiar right now with the latest version of Codex, you can see that actually if you ask the Codex, go to this website and I don't know, like help me to fill out this form or like go and grab this information. Right now, Codex actually have like this a small viewer where you can actually see in real time what the agent actually is doing. So which for myself, I think that this is something critical. Interpretability it should be something that is need to be considered when you are dealing with agents, and even more if you are like accessing users information and this kind of thing. So this is why we also try to consider that into the implementation of UISurf. um, I'm not gonna spend so much time this in the related system because this is not like a research talk, but I'm just gonna jump into more the practical aspects of the implementation. um, What else? As I mentioned, the evaluation in the literature is segmented by environment. Like we are trying to kind of bring specialized agents that can interact with the different environments. Um, in the literature, generally, you find like a lot of the work, but isolated depend of like like browser agents or web agents. There is so much work in the web arena or but we wanted to kind of like incorporate this into one single platform so and unified the way how we can interact with those agents. And cross-environment handoff is still under a specific and a system problem. This is one of the most difficult tasks. Orchestration. Orchestration is still being a challenge when working with agents. So this has been improved a lot with the last few years. And like right now, we have like very mature tools like Cloud, anti-gravity, and all of these codes, these agent first platform that have like really good orchestrators. But when you think about like interacting with user interfaces, the level of complexity add on top of that is that generally the interaction is asynchronous because you don't know when the agent that is actually trying to fill out like a form is going to be finished. So that means that you need to have a way how you can control all of this interaction in a synchronous way, but how you can make sure that you report back to the orchestrator or the, in this case, to the automation agent, so the automation agent can actually understand what is going on and what is the state of the task that's being on hand. So, so then what remains under specify is the operational layer, like section providing isolation, browser depth and mobile specialist coordination, human observation, interaction and guidance. So this is some of the challenges that we found that are more notorious. Um, some of the use case for this platform, imagine that you want to kind of like automate tasks like um, quality checking of user interfaces. If you want to implement an agent that go to the web to this website that you develop, and then you would like the agents to be able to provide feedback about the user interface, if the agent is actually loading, if the browsers are loading properly, uh, the user interface, if there is anything that can be improved, or maybe any kind of um, task related with checking the quality of the interaction with user interface surface. So UISurf can be used for this kind of tasks. But also, like you can play around and make fun with that and in other kind of application. And I'm gonna show you one of the use cases that we are testing into the platform. So this one is an example. For instance, expense reimbursement. So imagine that you go for a trick and then you take capture of your receipts and you need to create or fill out like a reimbursement report to your company portal. So then you can access the web to the mobile agents, go to, download the file that or copy the images that I have in my about the receipts that I have in my gallery, and then send them to my email, so then I can ask the web agents to go there and download it, and I can also ask the desktop agents to create a PDF that I can pack it and then send it to finish the reporting process. There is another other application. I'm gonna spend so much time on this, but because I don't have so much time, but this is another one, cross-device authentication off. These days, it's very common to have this system where you authenticate in one website, but then you need to go to the authenticator app in your mobile device, and you need to be able to have this kind of interaction with your mobile. So this is another application use case. You might go to Best Buy, Walmart, Amazon, find which the store that is the best, have the best price for the latest MacBook Pro, and create a text file on the desktop with the results. So now let's talk about how this system is implemented. So we have two different layers: the user application, what we call the control uh, panel or the control plane, and the runtime. And all of these three projects have been separated in different repositories, and all of them are gonna be open source once we have the preprint of the paper. Um, the UISurf app is where the front end and the orchestrator part is implemented. So the UISurf admin is the API that manage all of the Docker-based isolated sections that are created. One of the support that we need at this point, if you are an expert in Kubernetes, we are trying to see how we can scale right now the models that instead to use the Docker runtime directly to create the isolate sections, we would like to have Kubernetes. So we are, asking for collaboration in this regard. Um, and the runtime itself is just the isolated implementation of the different agents for the different user environment, like the UI environments, and all of them are exposed locally through agent to agent. And this is how they can interact with the, the orchestrator. So this splits separate three concerns that are often conflated in a UI agent prototypes: user interactions, sections control, and environment specific action execution. So this is from the prompt to well, this is kind of the end-to-end runtime flow. Users sign into the platform, submit attacks into the UISurf app. So the app decide whatever and manage UI section is needed. So it's create another section, or as I mentioned, you can just keep interacting in the same sections because the section are persisted. So then, if you need to create another section, you need to open it, you need to delete it or update it. You have this UISurf admin API that provide an endpoint for all of stuff related with provision and management of the sections itself. And we have UISurf agents. As I mentioned, the way that we design this is that we have an abstract class UI agent, and that abstract class is implemented from the specialized agent. This open the door for in the future we wanted to do like more specialized implementation. Imagine like a Raspberry Pi agent. So you can also have that because the idea or the main goal with this project is that provide the primitive where you can create specialized agents that are able to interact with different environments. Um, so this is the architecture components, and more like kind of for like in this visualization, you can understand better how they work. You have the users, so the user interact with this UISurf app, which have the front end, but also have this fast API backend where um, make possible the interaction with the multi-agent reasoning loop that have the planning agent, the automation agent, and the summarization agent. All of the system is implemented with the Firebase authentication. And we are right now using for the sections store, we are using Vertex AI agent sections management solution, but it's extensible to use other systems. So we have this USF admin platform, which is an API and which have a Firebase authentication as well. And this service is just we actually manage all of the section life cycles, and it's connected directly to the Docker daemon to like spin up like the container or this kind of stuff. So as I mentioned, right now we are also trying to think how we can make this model more scalable. If you wanted to contribute with that, we are happy to meet and discuss. Um, so we have different model provider support. So out of the box is provide Gemini support, but you can add new providers. We provide extensibility. Indeed, in the documentation, we provide examples where we had made integration with open-way models and open source models. And we have this sandbox container runtime that have the browser agent and the desktop agent. And using ADV and Android, so we provide support also to for mobile agents. So this is more details, kind of like view, but overall it's pretty much the same. This has a little more of the details that I just provide. So how the cross-environment orchestration actually happens? So we have the orchestrator that plans based on the user request, select the right execution specialist, and pass that information to the automation agent, which decides how to which agents need to be called and how is the sequence of how this agent they're gonna be invoked. And we have this specialized agent that provide the different, like the interaction with the different UI environments. All of the agents can be exposed through agent to agent servers, so the application orchestrators can call remote UI specialists as tool. And the design is intentionally close to the tool use loop using the model agent system. Um, but this also allow like the that this can be extended to other environments. So this is the orchestrator loop. This is kind of the algorithm. So user requests. So the user just pass a request, and so based on the request, so the orchestrator design use the UI and agents endpoints available in E. Let's call E like the collection of the available UI agents that are in the system, and the output is gonna be just the final response. So then, what's happening internally is that so we initialize first the agents that are available. So we pre-check which of those agents have been are already there. We use agent to agent, so we can actually evaluate those agents that are already um, available or not. So this is the three agents that we have right now. Um, so then, based on that, based on the availability of the specialized agents, the orchestrator do the planning and produce attacks. And in that tax plan, so it's include the objective, the assumptions, how this agent need to be called, which require specialists, and in what order they need to be called, but also what is the success criteria. Um, and then this pass that to the automation agent that is will actually resolve and execute the how this all of these kind of actions are executed, and all of this is because we queue all of the tags that every agent have assigned, so then they can actually check what is the current status of a given task. And this is overall how the each agents work itself. So each agent receives a request with the planned output, and what the output is gonna be is the automation report, or like so. Then this is I think that I have another algorithm here that explain better. Uh, yeah, this is the reasoning loop. So we have the task T. So imagine that the orchestrator decide that for a given task, you need to call the mobile agent. So that means that this task is assigned to the mobile agent. So then the agent itself is gonna use the model adapter. The model adapter is the abstraction that enable us to implement custom models. Right now we support, as I mentioned, Gemini, but we can add more support to them. And and then based on this information and the safety policy that we have defined, so he create an observation. The observation is just basically making a screenshot of the UI that is actually interacting and passing that to the model adapter. And in every interaction, because generally like a reasoning loop could require navigate through different pages. Imagine like I go to Walmart, but then after that you need to go and identify what is the text box or the search bar to write down the input and then do the search. All of these kind of actions are being stored in the memory, and because every observation is just like a screenshot, we can define how we can do the compaction of the history, but also we can actually like decide how many images we wanted to keep in memory. So this is completely configurable, and this depends of like how much token you have. And anyway, so this is overall how that works. I don't gonna spend so much time on this. I'm gonna go directly to the example because I am almost done with my time. So this is the what we're gonna be releasing. We're gonna be releasing the documentation of the three projects. This is the documentation for the UISurf agents. It's a Python library that provides the different implementation for the browser agent, the desktop agent, and the mobile agent. So you can see here a little bit how is the implementation of the agentic loop. They capture the UI observation, encode the observation, and pass that as the provider message. So then the model use that to generate a model turn, and based on that, we do the execution of the tool calls, which is generally like an action that is getting performed on the UI surface. So what you will find here is that, as you can see here, this is you start with a user task, and because each agent is exposed as an agent to agent, so you can actually use the agent from a Python API, for a CLI, or for an as an agent to agent endpoint. And then so you have this abstraction, and from this abstraction with the specialized implementation, and the loop and the agentic loop is generate the observation from the environment and then pass that to the model adapter. Here we can intersect and implement custom models. And then so we generate a model turn. Model turn is kind of like an output, and based on that we can decide how we're gonna do the tool dispatching, and how the controller is gonna take over and execute the task in the surface. So this is overall how that works. So we can also provide code examples of this is how you run the code. This is how you run the agent, for instance, the browser agent. So you say I want to create a browser agent. You have two different mode. Auto mode is the agents don't ask the user for anything. Or the other, if you pass this like a false, it's like a with human in the loop support. So you can pass the maximum observation images that you want to keep in memory, and those images are used for the context compression. And you also can specify how those screenshots are gonna be scaled. And then you pass the agent run, and you pass the task, and you can decide how many steps, how many reasoning loops you want to do maximum. And we have been create a schema to identify the different type of events that we can have. This is how you run the agents from code. If you want to run the agents in the CLI, you can also do that. Or if you want to run the agents as agent-to-agent servers, you can also do that. So the good thing about having the agent-to-agent server is that you can connect this with any cloud that you could have. And for the external models, I finished that, and to pass to the demo. We have also incorporated some models how to add support for custom models. For instance, we include the support of Farad 7 billion parameter, which is a model from Microsoft Research trained for computer use. So we also provide examples in the GitHub repository how to integrate that. And we also implement support for MolmoWeb, which is a model from agent or Allen Institute, when it's an open agent for automation of web tasks. So feel free to check the example. And to make it the example I create the tutorial, this is the overall UI. Just log in here, and then so you have this different section. As you mentioned, I have a section running here, so I can just click here and decide what kind of section I want to create. Is autonomous section, or a human in the loop section. So when you create that, what happened here is that there is a container that is going to be provisioned for the agents to be able to interact with, and in the container that is where the agents are actually running to do the automation of the tasks. And then here you can say use the browser agents to search for images of dogs. You can also use this improve prompt, and this improve prompt is like a tool, very simple tool that make the prompt more adapted to what the agent actually understands. So then you execute that, and so then the planner is going to tell you, okay, this is my execution plan, this is the objective, this is the assumption that I'm doing based on the missing information, this is the order execution steps, and you start taking over, and you can see in real time what is going on. You can close the section and get back, and then everything is going to be there. And I have a video right here in the meantime while this actually finished, when you can see a full complete example. So as you can see here, you have different levels of observability. You can know exactly like which agent is actually doing the performing on a specific task and the status, but also you can see the browser, and we also have the phone emulator here running. So we are also working on the front end. If you are a front end engineer that you want to contribute to the project, reach out. So we need somebody that help us to incorporate into the UI directly the phone kind of UI specifically. But yeah, we get back to the example. So we see that the agent was able to finish the task. But yeah, so this is overall the project. So feel feel free to reach out, and so we're gonna be releasing this very soon, and we're gonna be presenting the this project into the Agentic AI Summit. If you are attending, come and see our poster and our presentation. We're gonna be happy to have a coffee or a nice discussion about the project itself. So again, don't forget to join the. I don't know where's my slides. Yeah, please don't forget to join the Discord if you want to contribute, and also this is my website. So you can find there to the some of the other implementation that I have done in terms of agents, and some of the content that I generally publish about this. Thank you.